Hi everyone, welcome to another Nextflow tutorial for bioinformatics. In this video, I'm going to give you a script that you can use to generate your RNA-seq read count. So this is what the script does, all right? I mean the overview. So the script takes FASTQ files, pair them reads by the way, and then it trims them. So what you should place in are the raw reads. So it will trim the raw reads, and then the trim reads as well as the raw reads, QC will be done on them. All right, and then we can compare them. The trim reads will now be mapped to the specified reference sequence, and after that, we will generate our read counts using feature count. So this is what the script basically does. And so at the end of the day, what you are going to get is a read count matrix like this. Okay, so this is what you can place into tools like the seq2 to perform your gene expression analysis or differential expression analysis. All right, I've covered some tutorials on the seq2 that show how to input data sets like this. Okay, so I will leave the link in the description box for you to use. So I will show you how to run the scripts basically. So don't worry, I will show you everything. Okay, because it's automated. All right, so let's get back to the presentation. So for this tutorial, in order for you to use the scripts and get your outputs, you need to make sure you have the following requirements satisfied. You need to make sure you have Nextflow, you need to have FastQC, MultiQC, trim galore, star, and then subread. But don't worry, you can easily install these tools if you have one of these, Conda, Mamba, or Marco Mamba. All right, so I have tutorials that show how to install Conda and Mamba. So check the description box, you'll find the links to those videos. So use those and I will show you how to quickly install the rest of the tools. All right, so that's what we are going to do. So let's go to the terminal first and then let's install the tools. So I'm going to do this. I'm going to install using Mamba. But if you have Conda, you can just say Conda. If you have Micro Mamba, you can also say Micro Mamba. So I'll create an environment and I will install the tool. So I'll say Mamba create -n and I'll say RNA-seq. This is the name of the environment and I'll specify channel. So I'll say -c bioconda -c conda forge. Then I will specify the tools. I need Nextflow. I need FastQC. I need MultiQC. I need trim galore, so it's trim-galore. I need star. I need subread. These are the tools I need. All right. So what we need to do is to run this command to install the tools. So let's do that now. Okay, so this is what we have. So what we need to do is to confirm. Okay, so I'll type Y for yes. And once I do that, Mamba will automatically download the packages and install them for me. Okay, so just hold on tight and the tools will be configured for you. It will not take much time. Okay, so after a successful installation, you will see this test telling you how to activate and use the tools. So since I use Mamba, I see Mamba here. If you use Conda or Micro Mamba, you see them there, Conda or Micro Mamba. All right. So let's clear the screen and then let's activate the environment. So I'll say Mamba activate RNA-seq. Perfect, it's done. Now let's create a directory, a project directory, and then we'll use that for our working directory. So I'll say make dir RNA-seq, and then I'll cd into it. Perfect. Now I want us to get the example scripts that we will use for this exercise. All right, so you are watching on Patreon, so attached to this video you will find the scripts. All right, so you'll find 2 scripts. So these are the scripts. All right, you may likely see them this way. All right, or you may also see them as zip files. So if you see them as zip files, just unzip them. All right, that's what you need to know. So if you see them this way, just unzip them so you can open and then extract. all right, and then extract it and then use them. You can also use the command line to extract them, all right. So anyhow, you will have access to this script. So these are the scripts we need for this exercise. All right, so I'll move back to the terminal. Okay, so let's ls to see the script. Nice. So what we will need to do first is to get the example data, all right. So the get data.sh script will help us to do this. What we need to do first is to add execution right. So I'll say chmod plus x, and I'll say get data.sh to make it executable. Then I'll say / get data.sh. Alternatively, you can just say bash get data.sh. That also works fine. All right. So I'll say / get data.sh like this, and I'll run it. So once I do that, the necessary files will be downloaded and then organized for me on my system. So I just have to wait for everything to get done for me. All right, so the necessary files have been downloaded. So let's clear the screen and then let's do an ls. So when you do an ls, you are going to find a directory called fastkill, and you're also going to find a directory called ref. All right. So you can ls into the fastkill directory and you'll find your example fastkill files. Let's ls into ref, and we are going to find our reference sequence. All right, so there's what we have. Okay, now let's quickly take a look at the script. So there's a script rnaseq.nf. all right, I'll just display it here. So I have series of commands that allow us to process our RNA-seq data from raw reads to get us the read count. Okay, so a detailed explanation of this script can be found. Okay, I've already made a video, a separate video on that, so that's available on YouTube. So I'll leave the link if you want to learn more about Nextflow. All right, so if you just want to use it to get your output, then you can just stay tuned and then check how the script is run. All right, so let's proceed. So I'll get back to the terminal. So for the script, I've prepared a simple help statement that shows you how to use it. So let's quickly run that first. So I'll say Nextflow run, and I'll say RNA-seq nf. This is how we run it. So if you want the help statement, it's just --help. So when you run it, it's going to give you the usage. All right. That's how it's going to bring it up. So I'll just redo it again so that we see what is happening. All right. So we just do ls. So we just do ls. We see our files, ls fastkill, ls ref, and then I'm going to redo it again. All right. So to get a help command, it's just this simple statement here. So I'll run it again to see the help command, okay, to see the usage. So this is how it's going to appear. All right, so the usage tells us that we run Nextflow run, and we specify the script, which we just did here, and then we specify the reference file. Okay, we need a faster file, so we use this flag ref _ fast a, that's ref _ fast a, and then we specify the path to the reference sequence, the faster file, the fast a file. Then we need a DTF file. We use this flag --ref _ DTF. Then we specify the path to the DTF file. I'll show you with an example. Then we need the strandedness. So we say --strand, and then we give the strandedness. So strandedness here, it can be 0, -1, or 1. So you always have to check with your sequencing facility. They will give you the strandedness, and you can place it here. All right. Then --reads is used to specify the reads. Now you notice that when we come to the reads, we have single quotes beginning and then single quotes ending. So there's the format. And then you specify a pattern. We are dealing with paired end reads. So with paired end reads, we need to specify a pattern that tells Nextflow that these are pairs or file pairs. All right. So in this context, this is how you specify it. So here we need to take note of something. If you have your own data, you need to take note of the paired end reads, how they are specified. In this data set, for example, we can distinguish between read 1, read 2 using the underscore 1 and then underscore 2. All right, so read ones have underscore 1, read twos have underscore 2. Using 1 alone will not help because in the sample IDs, there are ones. The string or the character or the value 1 is also there. So just 1 will not be appropriate. But what makes them unique is underscore 1 and underscore 2. So there are different ways that the parent reads can be named. So you can check with your bioinformatician, or you can also contact me, send me a screenshot of what your data is, how they have been named, and I'll guide you as to how to specify them correctly and run the script. Okay, now let's run the script. Let's do an example here. So I'm going to show you so that you can also reproduce with the example data set that has been given. All right, so let's do this. So to run the script, we will say Nextflow run, and we specify RNA-seq.nf. We specify the FASTA file. So I'll say --ref underscore FASTA or FASTA. Then we specify the path to the reference sequence. So they are found in the ref directory. So I'll say ref/chr x.fa. DTF, we say --ref underscore DTF. And then we say ref/chrx.gtf. Then strandedness will be --strand. Here we will use 0, meaning unstranded. Now with the strandedness, you can also infer using tools. For example, you can visualize the BAM files using IGV, and you can use that to infer. There are other tools available. I will leave some links for you to check them out. Or just to be safe, consult your or contact your sequencing facility. All right, the facility that sequenced your data. Okay, now let's specify the read. So with the read, we say a --read, like how it has been specified here. All right, this is an example. So we'll also do same. So --read, single quote, and I'll say /star curly bracket _1, comma _2, curly bracket close, single quotes. All right, here we have to add something else. So we will remove the single quote and say *fastkill.gz. Then we bring the single quote. So this is how we are going to specify it. So if you are using your own data, make sure that you use the right pattern. It's very important. All right, so that's how we are going to run the script. So let's execute this command. Okay, so once you execute it, this is what you are going to get. All right, so trim galore for trimming, fast QC multi-QC. This is used for QC. So both the raw reads and the trim reads, we are going to run QC and then compare them. So reports will be generated. For the mapping, we will have star. So star will perform an indexing and then to map the reads, the trim reads. Then feature counts will be used to get the read counts, and then we'll aggregate the reports using this process. Okay, so if you want details on how to run this, then just contact me. You can book a session with me and I'll show you how to also generate some of these scripts. All right, so let's wait for the script to get done. So for me, it took about 3 minutes or so. So let's wait for everything to get done. And depending on your computing power, it might even take a lesser time. All right, so let's wait for everything to get done for us. Okay, so the script has finished its work. So we have all these. All right, so let's quickly explore the output, which I believe will be helpful for you as well. All right, so this is the project directory, or let's say the working directory. So the outputs index. So I'll start with this one. So indexing is the directory which has the files generated as a result of indexing. So when star indexes your reference sequence, you have these files. So that's what you have here. All right, we also have mapping. So this contains the BAM files as well as the star mapping logs. All right, so we have them here. So it is the BAM files here. One of them should be here. This is the BAM files that are used by feature count to generate the read counts. All right, so we have them here. We also have the read count for feature counts. All right, so this is what we generate at the end of the day. All right, so let's open this. I think I had earlier on opened it, but I will try to open it again for you to see. So let me pull this up right away. So this is what you generate. Okay, so it aggregates the read count for each of the samples. So you can have all of them in a single file, in a single spreadsheet like this. All right. So we have these gene ID, chromosome, start, and strand length, etc. All right. So if you are going to do gene expression analysis, differential expression analysis, then what you need, okay, for tools like the SIG2, what you need are the gene IDs as well as the count for the different samples. So that means you need this sample. All right. You need this, you need this, you need this, up to these ones, as well as an additional file, which we can discuss about later on. So this one, for example, you need to make sure you have properly formatted it. So the script allows for that. So the script generates another file called gencount.final, which is properly formatted. So I'll just open this. All right, so this is properly formatted. So if you are going to use your read count in the SIG2, then this is what you should use. All right, it's properly formatted for you, and then you can proceed with the gene expression analysis. So that's what you have. So this script also generates reports. Okay, I'll start with the trimmed read first. So these are the trimmed reads. Okay, we use trim galore to trim. So it is this trimmed reads that are used to generate the BAM file here, and then we now get the read count. All right, we also have reports. So we have reports that you can use here as well. Okay, so we have the report here. Okay, so this aggregate report from, let me just open it for you to see. So it aggregates reports from feature counts and also star and then FastQC. Okay, so it aggregates all these reports together for you, so you can quickly look at all the reports in this file. All right, and then also make your comparison. Okay, so both raw reads and then the trimmed reads, you have these reports that will help you to gain more insight or to know what has happened. All right, so we see all of them here. Okay, so this is it for the multi-QC reports. We also have this report, which is for FastQC only. I place that here, so I will say QC reports. So I'll just go over again. So we have this report called QC report. So in this report, you have the FastQC report. Okay, so when you open this folder, so this folder here, when you open it, it has the FastQC report for the trimmed reads as well as the raw reads. All right, so here you can easily compare. All right, so for example, this is for the raw reads. This is with one of the samples. I can open it, and I can also open the trimmed reads with one, and I can easily compare them. So there has been an improvement, right, after trimming. All right, so we have this as well as the multi-QC reports for just the FastQC. So I've also isolated just this one for you in case you want to get those reports. So there are lots of things you can do. You can customize the scripts to do many things, by the way. So if you have any question, you can just let me know with regards to the script usage. All right, so that is what you have. So since the ultimate aim for RNA-seq, if you know what bulk RNA-seq is, to do differential expression analysis, so then you go to your read counts. I mean, the files are there. So gen count final. This is what you are going to be using. All right, so this is it for this tutorial, and I'll come back with more automated scripts that will make your life easy. All right, so for beginners, You don't have to write all the scripts. I will try to, if you are subscribed to this channel, I'll try to make tutorials that make it easy for you to analyze your bioinformatics data. So I'll see you in the next session. And before you go, it's important that you remove the files. Let me just share the terminal. So there's a terminal, by the way. I'll just go back here. So in the project directory, the Nextflow work directory should always be removed. Whenever you run Nextflow, it generates it, so chances are there will be duplicate files which will occupy space, unnecessary space. So what you want to do is to remove that directory when you are done with your project. So I'll just do it here. I'll just say rm-fr work to remove that directory. All right, so I'll just remove it. And then for the rest of the data sets, that one you can maintain it, or you can also remove them if you want. Okay, so that's how we do it. All right, so I'll see you in the next session. Okay, so later then.